Here's what you need to know about bioretention from the Alberta Low Impact Development Partnership. Urban areas generate 20 times or more runoff than natural landscapes. Roads, lanes, and parking lots generate a lot of very dirty runoff. Bioretention areas can filter and cleanse large amounts of this dirty runoff in a small footprint using natural processes. You'll find them in the streetscape, as part of amenity spaces, in parking lots. Everywhere runoff needs to be cleansed. So what makes up a bioretention area? In some ways, bioretention areas are similar to rain gardens. Both are planted depressions that drain within about 24 hours after rainfall stops. But to handle all that dirty runoff, bioretention areas use special soil and plants. And where subsoils don't drain well, an underdrain gets added that ties into the storm pipes. An overflow may be added that can also tie in, controlling how deep water can pond before spilling. An inlet can take many forms and often has elements to slow down flows and trap sediment. And it all comes together like this. Runoff is absorbed into the soil after a gentle rain. In heavier rainfall, runoff will penetrate to the subdrain, with the cleansed runoff going into the storm pipes or infiltrating into the subsoil. In higher flows, runoff will reach the overflow. In the biggest storms, only the first few minutes of flow might be captured before bypassing the area. But that's okay, because most of the treatment that's needed happens during the smaller storms anyhow. In our dry climate, one variation that's popular in very urban areas is soil cells. These structural units allow sidewalks and plazas to float on top of bioretention areas and are planted with trees, enhancing our urban forest without the need for extra watering. You may have walked on one without knowing it. So what does bioretention treat? While other tools may focus on filtering sediment, bioretention excels at also managing dissolved contaminants, such as nutrients that lead to harmful algae blooms. Hydrocarbons, bacteria, pesticides, and metals are other common contaminants that bioretention handles, not to mention mitigating thermal impacts to cold water fisheries. While it is true that we will always need ponds and wetlands for flood control, for treatment, bioretention areas are actually a more effective solution over the long term. They provide patches of habitat and make neighborhoods greener, more walkable, and more livable. Where drinking water and crop irrigation source waters need protection to meet fisheries protection requirements and to reduce harmful algae blooms, bioretention is a critical part of the low-impact toolbox. For more resources on this and other low-impact solutions for the Northern Prairies, visit alidp.org.